Good morning to everybody. This is Dr. Brahmayya, Associate Professor of Chemistry, Department of S&H, MLR Institute of Technology, Hyderabad. Today I am going to talk about the mechanisms of the corrosion. So the overview: oxygen absorption mechanism, factors affecting the rate of the corrosion, galvanic corrosion. So factors affecting the corrosion. The rate of the corrosion depends on the following factors: nature of the metal, primary factor; nature of the environment, secondary factor. So these are the two factors. The nature of the metal, electrode potential, oxidation potential. When two dissimilar metals are present in contact with an electrolyte, metal placed higher in galvanic series, having lower electrode potential, becomes anodic and hence undergoes corrosion, and the other metal is protected. So in combination of the zinc and copper, and zinc undergoes corrosion, whereas copper is protected. So the activity or the more electroactive material, will always act as a anode. It will lose its electrons very easily when compared to the other metal. Both metals, though they are losing their electrons, losing electron property, but the more electroactive material, which can lose its electrons very faster than the next metal, that will act as always anode. Potential difference between two metals. Metals which are far apart in galvanic series have greater difference in their oxidation potential, and hence faster will be the corrosion of the anodic metal. So as we just discussed, the more electroactive material is always acts as a anodic part. So nature of the corrosion product. If the corrosion product deposited on the metal surface is uniform, stable, insoluble and non-porous, it acts as a protective layer and prevent the further corrosion of the metal. Relative series of the anode and cathode. If the ratio of the cathodic area to anodic area is more, the rate of the corrosion is more. If the ratio of the cathodic area to anodic area is more, the rate of the corrosion is more. Smaller anodic area leads to more rapid and severe and localized corrosion because of the more demand of the electrons by the large cathodic area. So if the anodic part is very small, cathodic part is very high, then cathode is always seeking the electrons. So it is happening more demand of electrons by the large cathodic area. So this is a smaller anodic area leads to more rapid and severe and localized corrosion. So this is why it is happening. More demand for the electrons is fulfilled by the small anodic area with higher current density and rapid oxidation, which leads to the increase in the rate of the corrosion. Purity of the metals. The impurities present in a metal form a minute galvanic cell with the metal under appropriate environment. The metal then acts as a anode, undergoes corrosion. Impurities such as lead, iron, zinc leads to the formation of the tiny electrochemical cells for a short periods. Here, zinc acts as a anode and its rate of corrosion increases. Pure metals have lesser chance of the corrosion. Because it's very pure. To remove the electrons from that pure metal is very high. It needs very high energy. Whereas some alloys compounds like with the metals mixed with some other metals, that will form very easily to lose their electrons. That will form their anodic part and cathodic part very easy. So thus the pure metal is always a very strong metal which cannot form corrosion very easily due to high energy needed to release the electrons. Physical state of the metal. The rate of the corrosion of the metal is influenced by the physical state of the metal, such as grain size, orientation of the crystal, stress, etc. The smaller the grain sized metals, the greater will be its solubility and hence faster it is the rate of the corrosion. Very simple. Like if the metal is in a size of the grains, small things, then it is very easy to remove the electrons from its surface. So it can form very easily the corrosion. If it is in a big size, it is very tough to remove the electrons except on the surface of the metal. The remaining part will be protected and it cannot lose its electrons very easily due to the size of the metal. Nature of the corroding environment, secondary factor. Temperature is always enhances the rate of releasing of the electrons from the metal surface. So that is very increasing factor to form the corrosion. Humidity. In a humid atmosphere, the rate of the corrosion is very fast. This is because the moisture acts as an electrolyte for the atmosphere gas like O2, CO2 to undergo electrochemical corrosion. Metals like magnesium, aluminum, zinc, copper, iron get corroded in the presence of the moisture, even in the absence of the atmospheric gases. pH of the medium. Higher is the acidic medium, lower pH, higher will be the rate of the corrosion. If acidic medium is very high, so it's very easy to form the corrosion, as we discussed in the earlier videos also. Most of the metals are corroded at the lower pH but resistant to the corrosion at the higher pH. So at pH greater than 10, it's like the alkaline solution. Alkaline solution cannot support the formation of the corrosion when compared to the acidic medium. The corrosion of the Fe stopped due to the formation of the protective hydroxide coatings on the iron. Why? Because of the alkaline solutions, hydroxide ions always tries to form the protective layers like aluminum hydroxide, iron hydroxide, like that. Ferrous, with ferrous ions, it will form FeOH twice FeOH6, like this. These are the compounds. Generally, protecting layers will be formed. Conductance of the medium. In case of the underground or submerged objects, the conductance of the medium plays important role as the corrosion current depends on it. The clay and mineralized soil has the more conductance than the dry and sandy soil, and therefore rate of corrosion is higher in clay soil. So it's a very high formation of the corrosion rate due to the mineralized soil. Due to the mineralized soil, there are many kinds of metals, many kinds of available metallic ions, so that very easily to form the corrosion in the soil. So this is the iron hydroxide. Galvanic corrosion. This is the corrosion. Galvanic corrosion. This is the aluminum metal. This is the copper metal. Both metals are combined together. They are very near to side by side, so that they will form like anode and cathode. So why anode is aluminum? Aluminum loses its electrons very faster than the copper, so that it is always acts as a anode, and copper will be act as a cathode. This is the mixing. These two metals are mixing here. This is the electrochemical cell will be here forms. Electrolyte will be, suppose, some moisture, some water, some any industrial solution will be poured here, or unfortunately they will come, that will act as a electrolyte. So automatically it will act as a it will be form a galvanic cell. So because of this galvanic cell formation, the corrosion will be formed. The flow of electrons will be generated and released by the anode and gained by the cathode. So this is the mechanism simply happened. This type of electrochemical corrosion is also called bimetallic corrosion. So due to the two different metals, it is a bimetallic corrosion. When two dissimilar metals are connected and exposed to an electrolyte, they will be form a galvanic cell. The anodic metal will be oxidized and it will be undergo corrosion. Zinc and copper metals connected with each other in electrolyte medium form a galvanic cell. Zinc acts as anode and undergoes corrosion, while cathode will be unaffected. So this is the galvanic corrosion. So for example, for galvanic, this is a iron and copper combinations. How this galvanic cell is formed, we can see here, and how the corrosion is happened is here. This is a iron board, and this is a copper. So this will form corrosion. Examples of the galvanic corrosion and prevention. Example: when zinc and copper are connected and exposed to corroding environment, zinc, higher in electrochemical series, forms the anode and undergoes oxidation and gets corroded. Copper, lower in electrochemical series, acts as cathode, undergoes reduction and protected as the electrons reached by the zinc flow towards copper. So the prevention: galvanic corrosion can be avoided by the coupling metals close to the electrochemical series. Fixing in insulating material between the two metals also, we can protect the corrosion. By using the larger anodic metal and smaller cathodic metal also. By using the larger anodic metal and smaller cathodic metal also, we can control the corrosion. Examples of the galvanic corrosion: steel screws in brass marine hardware, steel pipe connected to copper plumbing, steel propeller shaft in bronze bearing, zinc coating on the mild steel, lead tin solder around the copper wires. So in two different metals, so like as we seen in the last slide, so like this is one metal, this is one metal, so automatically the corrosion will be formed due to the formation of the anode and cathode. This is the actual concept we have been discussed just now here. So in the summary, it is concluded that oxygen absorption mechanism and the factors affecting the rate of the corrosion and the galvanic corrosion, examples of the galvanic corrosion and the prevention methods being explained. These are the topics we covered today. Thank you so much.